we're going to do about magnets and magnetic fields. So have a think about this do it now question to start with. What would happen if I push these two magnets over here closer together? Notice how they're lined up. So the two blue parts are close to each other and the two red parts are close to each other. And then what about on this side? What would happen to these two magnets where the blue side is next to the red side and the red side is next to the blue side? And then finally, think about this horseshoe magnet. What would happen if we put the paper clip and the button near to the magnet? Pause the video, write down your predictions. If you can, use science to explain why that will happen. And then write a list of keywords that you think we might use in today's lesson. Pause the video, and then when you're ready, press play. Are you back? Brilliant. Let's find out what we're going to do today. So our learning question for the day is, what are magnetic fields? You need to be able to describe magnetic fields. Most of you should be able to explain how we can use iron filings or plotting compasses to find the shape of a magnetic field. And some of you will be able to make predictions about the shape of a field and explain how field strength changes with distance. The keywords that I came up with for the lesson are magnet, pole, field, attract, and repel. What words did you come up with? Have you got any of the same words as me? Back to our do it now then. What are magnetic fields? That's our question. We're going to get to that shortly. But what about these magnets? So on the left, those two magnets, if we try and push them together, they're going to repel each other. Like poles repel. So each magnet has a north and a south pole. If we put a north pole next to another north pole, so in this case we've got the blue part next to the blue part and the red part next to the red part, they will repel. On the other side, we've got the opposite poles lined up. Blue is next to red and red is next to blue. So if we put those together, they come together, they stick together because opposite poles attract. Now our horseshoe magnet in the middle, if we put that near to our paper clip, the paper clip will be attracted, but the button won't. That's because paper clips are made of steel, which is a magnetic material, and buttons aren't. What part of a permanent magnet is the strongest then? And is the force from a magnet a contact or a non-contact force? Pause the video, have a think about it, and when you're ready, press play. You back? Brilliant. So the force is actually strongest at the poles of the magnet. So at either end of a bar magnet, you will experience the strongest force. And it's a non-contact force because the magnet doesn't have to be touching an object in order to act upon it. Some materials are magnetic, such as the steel in the paper clip, but most materials are not magnetic, such as the plastic in the button. Now, if we want to plot a magnetic field, we can use something called a plotting compass. The first thing we'll do is to put a blank piece of paper on the table, write our name, date, and title, and then draw around our magnet in the center of our paper. It's very important that you know this method. They often ask about it in the exams. Once you've drawn around your magnet, it's a good idea to colour it in so it looks exactly like the magnet that you're using. That will ensure that your magnet stays in the exact same position for the whole experiment. Then you'll take a plotting compass and place it next to your magnet as shown in the picture. A plotting compass is a small compass, very similar to the ones that we use for navigation and following maps. Once you place your plotting compass down, you need to use a pencil to draw a dot where the arrow points to. So here you can see this red arrow is pointing towards the side here. So if we use our pencil, we can draw a dot. Now we need to move the compass slightly so that that dot is now in the center of our plotting compass, like so. Now we need to draw another dot where the compass is now pointing. And we'll continue that process, moving our compass along each time so that it's centered over the dot. And we'll continue drawing our pencil dots until we reach the edge of the page or get back to the magnet. So that's our first field line drawn. What do you think this field line will look like? We've now moved the plotting compass down slightly, so it's now at this bottom right-hand corner. What do you think that line would look like? Pause it if you like to have a think about it. Then when you're ready, press play. Okay, so this experiment then would be repeated by just changing the position of the plotting compass each time. So we continue to move the plotting compass, put it in several different positions, all on the one half of the magnet. So on this example, we're always putting it on the right hand side of the magnet. And we follow our lines each time until you end up with a diagram like this. Then you can join all of your dots together to give yourself the magnetic field pattern. There is another way of finding the magnetic field shape, and that's by using iron filings, which are tiny little sprinklings of iron. We sprinkle them over a magnet that's on a piece of paper, and the iron will stick to the magnetic field. You can see there are large clusters of iron at either end because that's where the magnetic field is strongest, right near the pole. And then you can see that the magnetic field lines get further apart the further you get from your magnet. So they're all close together here, but they're much more spread out over here. And that's why the magnetic field strength is stronger at the poles of the magnet, because those magnetic field lines are all really close together. Whereas over here, they're further apart, so that force is not as strong. The arrows on field diagrams always point away from the north and towards the south. So they always go from north to south. Whenever you draw a magnetic field line diagram, you need to include these arrows and make sure they are always pointing from north to south. They often like you to complete a diagram like this in an exam. Right, let's see what we know so far then. The Earth has got its own magnetic field. That's how we can use compasses to navigate around. The compasses point north, and then we can work out which direction we need to go. But what does that tell us about the composition of the Earth? What must the Earth be made out of? For question B, look closely at this picture on the left over here. What three things on the picture tell us that the magnetic South Pole is actually the geographic North Pole? And finally, for C, explain properly how compasses can be used to help us to follow maps. Pause the video, have a good go at answering the questions, and then when you're ready, come back. Okay, you back? Excellent. So for question A then, the composition of the Earth. If it's got a magnetic field, it must be made of a magnetic material. Iron is a magnetic material, and the Earth's core at the centre of the Earth is actually molten iron. That's why the Earth has a magnetic field. What three things on the picture then tell us that the magnetic South Pole is actually the geographic North Pole? Well, we can see this from this big magnet in the middle that clearly shows the South Pole of the magnet is next to the geographic North Pole, and the North Pole of the magnet is next to the geographic South Pole. We can also tell it from the magnetic field lines because they always point from north to south. So if they are pointing from the bottom towards the top, then the bottom must be the north and the south must be the top. And then finally, we can tell from our compasses. These particular plotting compasses always point north. So, the red arrow always points north, and you can see our red arrows here are pointing north. And finally, how can compasses be used to help us to follow maps? Well, if you've ever read a map, you'll notice that they've always got a compass printed on the page. It tells you that the top of the page or the top of the map is north. So if you're not facing north when you're following a map, you will need to turn your map so that your map is facing north, and then you can follow the path correctly. So we use a compass to find out where north is, and then we can turn our map to work out which way we need to go. Right, some deliberate practice then. If you want an easy question, go for the red one. Medium questions, blue. And the green question is the challenge question. So pause the video. You can have up to 10 minutes to answer one of these questions in as much detail as possible. And then when you're ready, press play. Welcome back. I'm hoping you've now finished your deliberate practice. If you did the easy question, hopefully your diagram looks something like this. Make sure you've got your arrows going from north to south, and that your north and south pole are clearly labelled on your diagram. If you've drawn your diagram with the north pole on the left and the south pole on the right, that's absolutely fine, but your arrows should be pointing in the other direction. If you've done the second question, go back to the beginning of this video.